Okay, welcome back. In this video, we are going to find the inverse of a function. Now, we did this process before in 1010. Hopefully, it will be familiar. I'm going to do this function x over, no, that's going to be too hard. We'll start with something a little simpler. 1 over x plus 2, okay? Now, you probably don't know that this function is one-to-one because you don't know what the graph looks like. We are going to graph something like this later on. Actually, what the graph ends up looking like, you don't need to know this, but well, at least not yet. Do you need to know this? But it will have kind of a vertical asymptote at -2. And then it will be somewhat like kind of like a swoopy thing like that, and then a swoopy thing like this. Okay, that's what this graph actually turns out being. You will eventually have to graph this, but that's not this chapter. So it is actually one-to-one. Okay, so it has an inverse function, and what we're going to do in this video is just find the inverse. Okay, so how you find the inverse is there's kind of a process to it. Start by replacing the function notation, so like the f of x or the g of x or whatever, with y. Okay, so just replace that with y. It just makes it easier to mess around with the equation when it's y in there and not the function notation. So we're just going to replace that with y. Okay, now that we have y in there, remember an inverse function switches the roles of x and y. So what we do is we just switch x and y in this equation. So everywhere there's an x, put a y, and everywhere there's a y, put an x. Okay? So that's going to give us this x equals 1 over y plus 2. Okay? Okay? And then our goal becomes to solve for y. And that's basically all we have to do here now is just solve for y in this equation. Okay? So to solve for y in here, notice y is in the denominator. So let's start by getting it out of the denominator. I'm going to times both sides of this by y plus 2 on both sides. Okay, that will cancel that out from the bottom. Okay, so we get y plus 2 times x is equal to 1. Okay, once we cancel out that y plus 2 in the bottom. So that's a little better. Now we just want to solve for y. Okay, now there is actually a few ways that you could do that. You could distribute this out first if you want to do that, and then solve for y, or you could just divide by x on both sides and solve for y that way. Either way is fine. Okay. You will get equivalent answers either way that you do it. It's just they'll look a little different, but it will be the same thing overall. So with this one, well, I can do it both ways. Let's start by the distributing because I feel like that might be a little bit easier for you guys, but I mean, whatever floats your boat. So you get yx plus 2x is equal to 1. We just distributed that out there. And then we want to get y alone, so let's move this 2x over to the other side. subtract 2x on both sides. So we get yx is equal to 1 minus 2x, and now we just divide by x on both sides to get y alone. So what you'll get is y equals 1 minus 2x over x. Okay. Now, if you had done it the other way of dividing by x, you would get 1 over x over on this side, okay, with the 1, and then you would subtract 2. So it would just be 1 over x subtract 2, okay, if you did it that way. Notice these are actually both the same, because you could divide the x out of both of these things. You'd get 1 over x, and then minus the x's would cancel on that term to give you 2 there. So those are actually the same thing, just different ways of writing it. Okay, either one is fine, as long as you get kind of a correct answer here. Either one is fine. Okay. Now typically how they'll write the final answer is they will just use the inverse function notation. So that's with the little -1 on the function would equal, you could use either of these formulas, 1 minus 2x over x, okay? And that would be your inverse, okay? Okay, now if it's a linear function, it's a lot easier to solve for y. This one is a little bit more messy, but it's not too bad still, okay? In the next video, we're going to do this again, but with a slightly more complicated function where solving for y is a little bit harder, okay? So I think that's it for this. Hopefully that helps.